Hey you guys, it's Mrs. Abbott. We're going to talk about the rock cycle today, and you're going to take some notes. There's a link to the notes on Schoology. Otherwise, you can grab a hard copy from me or print that. Anyway, we already talked today about igneous rocks, so we're going to be talking about the other types of rocks and how they are formed. So, the three different types of rocks are igneous, which we learned about today, which can come out of volcanoes generally, or magma that cools close to the surface. There's also sedimentary rock, which is formed from sediments. And then finally there's metamorphic rock, which is formed when the other two types of rock go through intense heat or pressure. But all these types of rocks are subject to processes that change one type of rock into another. It's called the rock cycle, but there's a lot of different ways that a rock can move through the rock cycle. Before we get into each of the types of rock, it's pretty important to understand what weathering and erosion are. And we see evidence of weathering and erosion here in Vermont all the time. In order to make sedimentary rocks, you need sediments. And sediments are the products of weathering and erosion. So weathering is when rock gets broken down by either physical or chemical means. And this picture right here is of a root passing through a rock and causing it to crack. Frost heaves that we have all over our roads are often formed from sort of that mechanical weathering or physical weathering when ice gets between cracks in rocks and then breaks. And then chemical weathering happens when minerals, salts, and other chemicals get into rocks and cause it to break down. Erosion is when you actually take that broken rock and move it someplace. So it's the process in which the material of Earth's surface get loosened, dissolved, or worn away, and then transported from one place to another by some sort of natural agent like wind, water, ice, or gravity. So this is showing erosion, these four pictures here. And we see that during the spring runoff. You'll often see a lot of sediments carried away by the water rushing over. Sometimes wind is an agent, other times ice, glaciers, and just simply gravity are all erosion agents. So igneous rock, I'm just going to go over really quickly. You don't have to take notes on this because we talked about it in class. But if you remember, that's formed from cooled and solidified magma. It's either intrusive, which means it was cooled within the Earth's crust, and it cools slowly and has really large crystals, or it's extrusive, which means it was melted on the Earth's surface or in the sky as it was ejected out. It cools rapidly, and it's fine-grained. And that's just showing you pictures of the different types of igneous rocks and formations that are formed because of it. Igneous rocks are either felsic, which means they're light-colored and have high silica content and low magnesium, or they're mafic, and they're dark-colored, low silica content, and they're high in magnesium and iron. Sometimes they're andesitic, which are medium silica, so they're like greenish, grayish brown. So sedimentary rocks are the first one I want to talk about today, and then we'll talk about metamorphic rocks. But these are rocks that are formed from the debris of other rocks and or living matter. 90% of the Earth's crust is made from igneous rocks, but 75% of the land surface is covered with a thin layer of debris or sediments, and this becomes sedimentary rocks. So those sediments, they settle in the beds of oceans, lakes, and rivers and get recompacted over millions of years and form sedimentary rocks. This is a picture I took in Utah, and you can see the different layers and the different colors of rocks that have since been eroded away and weathered, but those are the layers that were deposited. So sedimentary rocks are formed by a process called diagenesis, which is basically when you turn loose sediment into rock. So the way to do that is to really smush it and then cement it. So compaction is when you squeeze the sediments to form hard rock. So over the course of millions of years of rock laying on top of another rock, or sediment laying on top of another sediment, you get compaction. But you also need to get a little cementation, and this happens when the compacted sediments actually bind together with chemicals like calcite, silica, and iron. And this is just showing you the interplay. So there's sediments that get taken down a river and then deposited on the bed of an ocean, and they get, over time, more layers get compacted and compacted, and cementation happens. And you actually sometimes get ripple marks in sandstone because of that, because of the sedimentation that happened on land. There are three main types of sedimentary rock. The first type, they're called clastic, kind of rhymes with plastic, and they're formed from rock fragments that were weathered and eroded away by wind, rivers, and waves. They can be, they can have material of all different sizes. Organic sedimentary rocks are formed from the remains of plants and animals, and this is called breccia, and you can actually see the little shells in there. Limestone is another example, formed from the organic material from other organisms. And then finally, you can have chemical sedimentary rock, which is rock made from chemicals dissolved in water. That's called rock salt, and that's a classic example of chemical sedimentary rocks. This is a picture of my brother's dog in Utah, and you can see that there's all these different bedding planes in there. Jackson went to the Grand Canyon, and he saw this quite well, but it's just the boundary between one layer of sedimentary rock and another, and you can kind of see what the parent material was that came down and settled there. Metamorphic rock. Metamorphosis means to change. So this is formed from other rocks as a result of intense heat, pressure, and chemical processes. Most form deep beneath the Earth's surface, but some form at plate tectonic boundaries. And they're always formed from existing igneous, sedimentary, or metamorphic rock. Contact metamorphism is when hot magma pushes through rock that already exists and changes the structure but doesn't melt it. Only rock near the magma gets changed. I thought I had a picture there, but I do have a picture. Hold on. Regional metamorphism happens when one plate moves against another, creates heat and pressure, and affects the rock over that area over many thousands of kilometers. So here's a picture showing a magma chamber, and the rock near it changes because of heat, but it doesn't actually melt into magma. And then this is just showing you the bedding plane of sediments that get foliated or folded, intense pressure from plate tectonics. And finally, there's two types of metamorphic rock. There's foliated, which is shown on the left here, which has visible parallel bands of minerals like slate and schist have that. And then there's unfoliated, which has no bands of crystals, so quartzite and marble. You can see different patterns in there, but you're not seeing the actual banding pattern. So here's a picture of the rock cycle, and I want you guys to fill in what is happening here. First, in order for the rock cycle to happen, you need material, and usually that material comes from magma, which cools, and magma that cools becomes igneous rock, and that igneous rock could be cooled quickly or slowly, internally or externally, but that's the cooling of magma makes igneous rock. And remember, there's intrusive and extrusive. That igneous rock can then either melt back into magma, or it could get weathered and eroded, and that then becomes sediment. Sediment is not a rock yet, but it is something that can go through compaction and cementation to become sedimentary rock. That sedimentary rock can then get weathered and eroded back into sediment, or it could get heated and pressurized and turn into metamorphic rock. That metamorphic rock could then get weathered and eroded into sediment. It could get melted and turn into magma. And then the igneous rock that we had talked about before could become heated and pressurized and become metamorphic rock. So you can see it's kind of like a choose your own adventure. Each type of rock can become the other, and depending on where it is, that's going to determine its pattern. And we're going to play a game in class on Friday where we sort of figure out where we go as a rock in the rock cycle. Hope this helps. Enjoy your sunny days.